Okay.
So we have the first question here. Okay, says find the reduction formula for each of the following. So the first question we're going to look at. Okay, so we want to find the reduction formula for xm, natural log of x. If you notice in the sheet, just natural, there's a mistake there to be an x here, and then to the power n, then the x. So I want to get the reduction formula for this. Okay, so the first thing you're going to do here, every time you're finding the reduction formula of something, make sure that you do what? You use integration by parts. Okay, use integration by parts. So every time you're using integration by parts, you know that you have to choose which function you're going to integrate and which function you're going to differentiate. So you have two functions here, okay, x power m, natural log x to the power n. So you have to choose which one is it. Now you can easily integrate and also which one you can easily differentiate. So I always say this, you have to follow this order, okay? So this order here is very important. When it comes to choose a function, you are supposed to differentiate, okay? So the first one, logarithms, have the first unit, logarithms have the first priority, and then the next thing is the inverse trig. Inverse trig functions have the next priority, right, in the order. And then next is algebraic functions, okay? Algebraic functions have the next next priority, okay? And then next just trigonometric functions. Trigonometric functions. Are you able to see properly?
Yes, I can see.
Okay. And then the last one which have very like least priority when it comes to choosing which one will be the function you're going to differentiate. What? Exponential functions. Okay. Exponential functions have the least priority. So we follow this order, L-I-A-G-E, laity. I don't know how you can pronounce this. So you have to, the first thing you have to choose which function you're going to do differentiate. So when it comes to choosing, you follow this order here. Based on the two functions given, which one appears first in that order. So you can notice here, we have, this is the algebra. It's an algebraic function, x raised for anything, whatever. This is an algebra function. And then you have what? You have logarithmic function, which is natural log in this case. So as you can see here, natural log actually appears first now or in our order there. So we're going to make u to be equal to natural log of x raised for n. So that's the function we're going to differentiate. So I'm going to say let u equal to natural of x raised to power n. Well, what remains there will be of dv. So dv is a function you're supposed to integrate. Okay, x power m dx, that's the dv. Okay, so just recall, remember that every time you're integrating by parts, let's have a function u dv. This is equal to v u or uv minus the integral of v du. So what you need to calculate from this is actually to identify your u. So you have identified here what is your v. Your v is what you get after integrating dv. You can get your v after integrating dv. Okay, and du you get du after differentiating u. So you have to differentiate this guy here. So we're going to substitute in that formula. So first of all, let's get du. Du is gotten by differentiating u with respect to x. So du equal to, okay, you're going to differentiate this guy with respect to x. So this is du dx. Okay, so what's the derivative of natural log of x is for n? So I'm going to use power rule here. We drop n, okay, and then we reserve the same function inside here, and then we subtract 1 from n, okay? Subtract 1 from n. Now, since you're using chain rule, don't forget you have to differentiate again the inside function here. What you have done here, just differentiate the outside function, which is n. You just differentiate n by dropping the power and then subtracting 1 from the power. Now I have also to perform the derivative inside there. So the derivative of natural log of x is simply 1 over x. Okay. That's the derivative of natural log of x. So that this overall just becomes then write this as n over x, okay, natural log of x raised to power n minus 1. Okay, and then remember we need du. So we're going to make dx, we need du, we're going to make du the subject formula here by multiplying the equation by dx. So our du therefore becomes n over x, natural log of x raised to power n minus 1, and then dx. So we have found your du. Okay, so that is our du. The next thing you have to find v. So you can get v by integrating that. Okay, so remember that we have dv. So our dv is equal to we have x raised to power m dx. So let us integrate this so that we can get our v. So our v just be the integral. So when you integrate dv, you just get v. Okay, and then let's integrate x for m with respect to x. So we're going to use power rule. System as let's say you're integrating x squared. What do? You add the power, okay, and then divide by the new power, isn't it? Okay, so we're going to have x for m plus 1 divided by m plus 1. Okay, now we've got everything. We can just now go back and substitute that in our formula. Okay, remember that we are trying to integrate it. Okay, x for m, natural log of x raised to power n dx, and then u times v. Okay, our u, we found our u was what? Our natural log of x by that. So natural log of x raised to power n, that is our u, we chose. Our v is simply x power m plus 1, and then divided by, we're dividing this by m plus 1. Why m plus 1? Because this v is n plus 1, right? So it's what I could just right? That's analysis over m plus 1. Okay, and then minus the integral. Okay, and then here inside the integral, what do you write? We need v du. Okay, so our v, we found that. So our v times du. So our v is x for m plus 1 over m plus 1. And then our du, what is our du? Our du, we found our du as this here, n over x, and then times the other stuff. Okay, so which is the times n over x, and then natural log x raised to power n minus 1 dx. Okay, and then we just need to do a little bit of simplification here. We have to simplify this. Okay, so we have natural log of x raised to power n x or m plus 1, and then divided by m plus 1. Okay, at this point, I need to factor out what is constant, right? Remember that we are integrating this with respect to x. So anything that is not of x, which is not a function of x, please just push them outside. So this n can be put outside. Also, n plus 1 can also be put outside. So we have n over m plus 1. Okay, and then the integral x is for m plus 1. And then we also have 1 over x. So this is, we can just say over x here. Okay, this 1 over x, I just write here over x. And then natural of x. Okay, now natural of x raised to power n minus 1 dx. Okay, so at this point now we are almost done. Okay, we're almost done with our problem. So natural of x raised to power n, x raised to power m plus 1 divided by m plus 1. Okay, and then minus what do we have here? Okay, so you notice that okay, pay attention to this here. So you have x power m plus 1 over x. Okay, if you notice very well there, you're going to see that this actually can be divided out. Okay, so it's more like you have x, that x power m plus 1. You know that every time we have, let's say, a raised power n over b raised power over a raised power m, different powers, that as long as they're the same bases, this can be subtracted, isn't it? So n minus m, isn't it? Okay, so this is raised power 1, so you can write those two as x raised power m plus 1 minus the power of the denominator here to just 1 as well. So what you're going to end up having there is just the x power m. Okay, so this just simplifies to x power m. Okay, so we have n over m plus 1. So this just simplifies to x power m, and then we have natural log of x first power n minus 1 to x. Okay, so this is what you have now as our reduction formula. Okay, this is what we have as our reduction formula. Okay, any question?
Oh, so it's just integration by parts.
Yes, integration formula is just all about integration by parts.
Okay.
Yes, yes. Okay, so let's look at the next question. Okay, let's look at the next question. So the next question from your story sheet is about how you can get the reduction formula for sec. Okay, for second. So that's our next question here. So part 2. Let me say B. So I start with A. So this B. So we are getting the reduction formula, okay, for sec raised for any value, okay, and then dx. Okay, so remember that n must be an integer, okay? N is an integer, okay? N must be an integer, 0, okay, 1, 2, 3, and all that. Okay, so now for us to do, if you notice here, we only have one function. You can say that we only have sec n x. So we have to replicate this sec x so that we don't change anything to that. So every time we are given one function, like let's say tan to the power, sine power, you have to manipulate that function so that it can produce two functions. Okay. What's the reason behind that? The reason is that you have to choose now from that which one is going to make your u and which one is going to make your v. Okay, so at this point we don't know yet, okay, because just have one function, but we can split this n x into two functions. Okay, so why? Okay, let's before you split, what's the reason why you have to split that? You have to split in such a way that if you have those two functions, one of them, it will be easy for you to integrate. The other one also, it will be easy for you to differentiate. Okay, so for sec, always make sure that you split it this way. So sec, so this I'm going to write this as a, so sec for n, let me just write it here, for nx, this is the same as the product of two functions, sec for n minus 2x, and then sec squared x. If you notice, I haven't changed anything here. Okay, why have I chosen sec squared of all things? I know that the integral of sec squared will give me tan, so it means it's easy for me to integrate this sec and to give me tan. Okay, because I know if I differentiate tan x, I get sec squared x. So it's not by chance that I had to choose sec squared. No, it's because I know the integral of sec squared itself. So I know if I integrate sec squared, I'll get tan. It will be very easy to integrate. And then also differentiating this one as well, it will also be easy. Okay, it will also be easy. Now imagine if you had chosen sec nx to be sec n minus 1 x sec x. This would be so like very difficult for me to do, even for you, because the reason being is that yes, you can differentiate this sec n minus 1 to be very easy to differentiate, but do you know the integral of sec x? Okay, do you know the integral of sec x? That would be something hard to do. Okay, so that's the reason I have to choose sec squared x, because the integral of sec squared x is just very, very straightforward. Okay, so the identity we're going to replace there, sec nx will just be this. So in place of sec nx, I'm going to replace sec n minus 2x and sec squared x. Okay, so let's replace that. So the integral of that becomes we have sec n minus 2x and then sec squared x dx. Okay, so this is what we have now. Now from this, remember that we have now two functions that we wanted. Now we can make one of these u and the other one v by differentiating one and then integrating the other one. Okay, so let's do that. Okay, so which one are going to integrate here and which one are going to differentiate? Since they're both sec, now the choice is up to you to make. Okay, which one is easy for me to integrate and which one is easy for me to differentiate? And just like I mentioned earlier, sec squared, the integral of that just be tan x. So don't be such complicated thing. So I'm going to integrate sec squared, and I can differentiate sec n minus 2x. Okay, so this means that my u becomes sec now n minus 2x. That is my u.
Steve, sorry, let
Yes,
me
please.
just take you back a bit. Up on the, like where we split the two functions, I think I didn't get it very clearly. Where we, on where
Oh,
we
thank
have
you.
sec, yeah.
Okay. Look, I had, okay, so the first thing that came into my mind, or even if it's you are doing it, okay, which function from sec, I can take which function from sec, which would be easy for me to integrate. I know that sec squared, I already know that sec squared is just an x, right? So I have to make this, I have to take sec squared out of this guy, isn't it?
Okay, yes.
So I had to take sec squared out of sec nx, because I know it's easy for me to integrate sec squared. So this is what I did. Okay, now remember that I don't have to change this equation. It has to be the same. Okay, so if I write sec squared here, it means that from sec n minus x, I've subtracted 2, such that if I add these powers back, I get back sec nx. Okay, similarly, if you have chosen sec cubed, for example, if you have chosen sec cubed as a function which you know you can easily integrate if you know that function, then it means this one's supposed to be what? Sec n minus 3. So that if I add these powers, I'm able to get back to my sec n here. Is that okay?
Yes, it is.
Oh, okay. Let's proceed now. Let's proceed. Thank you. So we are going to make our u equal to sec n minus 2x. All right. So let me differentiate this. Remember that every time we make u equal to this or equal to something, make sure that you differentiate it as well, okay? So let me take the derivative of this function with respect to x. So I'm going to say du dx, this is equal to, okay, I'm going to use it, power rule as well as chain rule at the same time. Don't forget that. Okay, so if I have a function, f of x raised to a constant, okay, let's say n. So every time I differentiate this guy, I drop the power itself, and then keeping what I have inside here, subtracting 1 from the power, and then differentiating the function inside here, okay, which is f prime of x. That's power rule as well as chain rule at the same time. Okay, so that's exactly what I'm going to do here. So first of all, I'll drop that power. So the power for this function is what? N minus 2. So I'll drop n minus 2. In fact, this one, you can see it like this. Sec x raised to power n minus 2. If you want it that way. It's the same thing. Okay? You can add this as sec x raised to power n minus 2. So that if you differentiate this guy, you drop n minus 2. Okay? I'm going to drop this n minus 2. And then I'll keep sec x inside here. And then I'll subtract 1 from this power here. This becomes now n minus 3. Okay, and then times the derivative of sec x. What is the derivative of sec x? The derivative of sec x is simply sec x tan x. Please, this is very important. Okay, sec x tan x. How is this sec x tan x as a derivative of sec x? Remember that sec, okay, remember that sec x is simply equal to 1 over cos x. Okay, remember that is equal to 1 over cos x. So this can be also written as what? Cosine of x to the power negative 1. Or if you like, you can use quotient rule actually. Yes. So how can you differentiate this one here? You want to differentiate 1 over cos x, right? So first I'll differentiate the function on top there, which is just 0. Times the function down here is cos x. I'm sure I remember how to use quotient rule. And then minus the derivative of the function in the bottom here, which is a negative sign. That's the derivative of cos x, right? Negative sign x. And then times the top function just 1. Okay, divide by the bottom function is squared. So cos x squared. Okay. So you notice that what you're going to have on top here just be negative sign, because the first part is just 0. This just be positive sign. X down here of what? Cos x squared. So this cos x squared, I can add this as cos x times another cos x. Okay. So you notice that you can split this as 2. So sin x over cos x times 1 over cos x, right? If you notice that. So when you split those two, you notice that sin x over cos x, this gives us tan x. And then 1 over cos x, that is sec x. So you can just know it by heart that the derivative of sec x is simply what is sec x tan x. Okay, I think that is clear.
Yeah, it is.
Okay. All right, so we move. So this is what we get as our du dx. Now let's go for du. Remember that every time we have to evaluate du, right? So du becomes n minus 2 sec x n minus 3. Okay, and then another sec x tan x, and then dx. Okay, now we can do a bit of manipulation here. Okay, we can do a bit of manipulation, I think. So you see that you have sec. Okay, it's fine. Let's just keep it the way it is here at the moment. Let's keep it the way it is. Now let's go and replace this in the integration by parts formula. Remember the integration by parts formula is v u minus v du. So let's replace that. So remember that we're integrating sec n x dx. So our v, remember that our v was what? Oh, I haven't found the v yet. Okay, sorry. I haven't found v. So v have to integrate sec squared. So what remains is dv, of course. So our dv is equal to sec squared dx. So I need to find v dx. So our v, by integrating both sides, so our v becomes what's the integral of sec squared x? This is just tan x. Okay, so integrate sec squared x, we just get tan x. Now we can just replace this in our integration by part formula. So I have sec n x dx is equal to u times v. So our u, we said, is sec n minus 2x, and then times tan that. Okay, so this, the product of those two will be tan x sec n minus 2 x, and then minus the integral, and then v du. Okay, so our v is tan x, and then our du, what is our du? So our du is just what we found, it is n, but that our du is n minus 2. Okay, and then sec. Okay, so this is sec n minus 3. I can also write this is okay, x, and then another sec x and x dx. I'm just substituting everything there. Okay, now just like before, we need to pull out what is not a function of x here. In short, we need to pull out what is a constant. So notice that n minus 2 is just a constant there. Okay, so sec nx dx, this is equal to tan x sec n minus 2x minus. Okay, so we need to put the constant, which is n minus 2. Okay, and then we have this tan and this other tan. Those guys can be multiplied to get tan squared x. Okay, what else can we multiply? Okay, you notice that this sec. Okay, if you notice, this is sec n minus 3 x, and then sec to the power 1. You can add the powers of these guys, right? You notice that those sec, they have the same basis, so the powers can be added up. So we're going to add the powers n minus 3 plus 1. So we're going to have a sec, which is less for n minus 2 alone. Okay, are you able to notice that?
Yes, I'm able to follow.
Yes. So these two will produce sec n minus 2. I'm saying these two produce sec n minus 2. Okay, so you have sec n minus 2x dx. This is what you get as a result. Okay, are you following?
Yes.
Okay, so we have one more job here. Okay, the introduction of this tan makes everything miserable here, because if maybe you don't have sec n minus 2, would have stopped here. But this tan has to go. We have to get rid of this tan x squared. Okay, so how do we get rid of this? We need to make use of the identity. Do you remember that 1 plus Okay, 1 plus tan squared x is equal to sec squared x. This identity. Okay.
Yes.
So this is a very common identity we're going to use at the moment. So I'm going to make tan squared x the subject of formula. Okay, so that I have, remember that I have to get rid of that tan. So tan squared x, this becomes sec squared x minus 1. So I can just now replace this sec squared x minus 1 there. Okay. So we go. So we have sec n x dx. This is equal to tan x sec n minus 2 x and then minus n minus 2. So in place of tan squared x, I'll replace sec squared x minus 1 and then times sec n minus 2 x dx. Okay. All right. So you notice now there's something that we can do. We can manipulate this. We can distribute this, right? If you notice that, we can distribute that so that here we have. Okay, so it's a bit long, the reduction formula for sec squared, so sec n. Okay, so tan x sec n minus 2x minus n minus 2. Okay, so wow, so this is what we're going to do here. We are going to multiply this by that. Okay, you can multiply those. Notice that you do the multiplication, the powers have to add up. Why? Because they're the same bases. Okay, is that okay? Hello?
Yes, it is. Yes.
Yes, so you have sec squared x here and sec n minus 2. You can easily add these powers here, right? So 2 plus n minus 2, you don't say that you're just going to end up with what? Sec n x, isn't it?
Mm-hmm.
Okay,
Yes.
so just end up with what? Sec n x, something that is already with. I think this is what we want, okay? And then again, negative 1 by this sec squared, sec n minus 2, you're going to have minus sec n minus 2 x, and then the whole thing by dx. Okay, I've just disputed it. I've just opened the bracket there and then disputed everything. Okay, so now this is what you have. These and these are the same. This is what you started doing. So you have to make sec nx the subject of formula. That's the next step now. Because remember that we are trying to integrate sec nx. We're going to make sec nx the subject of formula. Okay, so let us manipulate this a little bit. So the integral sec nx dx, this is equal to tan x sec n minus 2x minus, here I'm going to distribute these integrals. Okay, so the first integral will have n minus 2, the integral of sec nx dx, so this also get them. Another one again, this negative 1, and then this negative 1, this will be plus. Okay, and then again n minus 2, this now contains sec n minus 2x dx. Okay, now this is it, the part of interest for me, because this is what I started with, because I wanted to find the reduction formula for this. So what I'll do, I'll take this guy to the other side of the equation here. Okay, so that's what I'm going to do. Are we together? So that now I can add up, I can add it to this, because they're like terms. As you can see, those two are like terms. So I'm going to add it this side, right? So I'll add this both sides of the equation. So what I'm going to have here is sec n x dx plus another one, which is n minus 2. So it needs to become plus, right? N minus 2, the integral sec n x dx. And then this side of the equation just a minute what? Tan x sec n minus 2x, and also what else? Plus n minus 2 sec n minus 2 x dx. Okay, so if you notice here, something is common. Okay, what is common here? The integral of what? Sec n x dx. Right? So I can factor out what is common, isn't it?
Mm-hmm.
Yes, so I can factor out what is common here. So I'm going to factorize sec n x dx. Open brackets. Okay, this is here I've factored out. So what it means is just a 1. So the 1 here plus what is meaning here just n minus 2, isn't it? Huh? We have something like this, isn't it?
Hello.
Hello. We have something like this.
I'm here.
Do you agree? After factorizing this integral? Okay, because here I factored out this, I just mean it a 1. Factoring out this, I just mean it n minus 2. Okay?
Okay. Yes.
Yes. So this side has to have tan x sec n minus 2 x plus n minus 2, the integral of sec n minus 2 x dx. Okay, so at this point now I can simplify this. So notice that I can add this n plus 1 minus 2, so that is just n minus 2 or n minus 1. Okay, so we're almost there now. We're almost there. This is just n minus 1. Right? If I add those two, right? Okay, I just have n minus 1, and this is equal to tan x sec n minus 2 x plus n minus 2, the integral from sec n minus 2 x dx. Okay, now at this point I can divide by n minus 1 both sides. Okay, throughout that. That's what I'm going to do. I'm going to divide throughout by n minus 1. So that I just have now, okay, sec n x dx is just equal to tan x sec n minus 2x over n minus 1, and then plus this is n minus 2 over n minus 1, the integral sec n minus 2x dx. And for this one, it takes the values of n. If you can see, the values of n should be greater or equal to 2 strictly. You know the reason why that's the case?
No.
The reason that's the case is because
Is it because,
yes, please. It's what? Because of what?
is it because and the 2 is the highest power? I don't, something like that.
No. The denominator here, you want to make sure that the denominator is not equal to 0, right? Yes. So you have to make sure that the denominator is not equal to 0. Okay, so if you put a 1 here, just notice that they're going to have a 0. So I'm trying to avoid that. Okay, you're trying to avoid that. Okay, that's what I'm trying to avoid. Okay.
Okay.
Yeah. Because you notice that if you just say n equal to 2, have you seen what is going to happen? When you set n equal to 2, you're going to have this x squared x dx. And there was the integral of x squared x, just an x. The reason being is that this would be sec to the power 0. This would just be 1. You're going to have 2 minus 2. We're going to have a 0. So what we're going to have is just an x.
Yes.
You notice, right? Yes. So this is n is strictly greater or equal to 2. All right. So that is the deduction formula for sec n x x. Any question?
No.
No question?
Okay. Third, but I think it's okay. It's clear.
It's clear. Okay. So what of the reduction formula for sine? Okay, let's see. So let's see. the reduction formula for sine x. Sine the power n x dx. Okay, so that's the next thing we're going to look at now. So how do you get the reduction formula for this? Okay. So remember again, just like the previous case we had for secant, you see that here again you just have one function sine, isn't it?
Which
So
is sine x. Yes.
we have to split this as well. So you know that okay, sine, integrating sine is very, very straightforward. Okay, integrating sine is very, very straightforward. The reason being is that the integral of sine just becomes negative cos, right? So I have to write this in terms of the product of cosine functions. Okay, so just a minute. So I have to write this sine as a product of sine functions. So the only way I can add this without changing anything, remember that if it is sine, so remember that I can integrate sine x, right? So I have to multiply this by sine x. So I'm going to have sine x. So this is sine power 1. So to mean that the other one should what is sine n minus 1 x. You see, just like we did before. So that if I add these powers of these two functions, I get back to what sine n of x. Hello?
Yes, Amir.
So that's what we have. So I'm going to have sine x and sine n minus 1 as a substitution for this. Okay. So let's substitute. So I have sine x, another one will be sine n minus 1 x as well, and then dx. Okay. So from this again, you know that we're going to make u to be equal to what? Sine n minus 1, right? So u is equal to sine n minus 1 of x dx. Okay, so let's differentiate this guy. So du dx. Remember, this also can be written as well. Don't forget, this can be written as sine of x raised to power n minus 1. Don't forget that.
Yes.
Yes. Oh, sorry for this dx. It shouldn't be there. Okay. This dx shouldn't be there. So now let's differentiate this. So differentiating this first, drop the power. So this is n minus 1. And then multiply by the same function. And then subtract 1 from the power. So I have n minus 2. And then don't forget to differentiate the inside function as well. Okay. We differentiate the inside function as well. So this becomes what? Cos. Cos x. Okay. So from this you can make it the du, the subject formula just like we have done before. So du is equal to n minus 1 sine n minus 2 and then cos x and then dx. Okay. So we have found our du. Now let's find our v. So our dv is what remains after taking out our v, our u. So our dv is simply sine x dx, and then integrating this both sides. So I'm going to have our v equal to what is the integral of sine x? This is negative cos, right?
Negative cos, yes.
Okay, so that's it, our v. Now let's substitute this in our integral formula for our integration by parts. So remember that we are trying to integrate sine n x dx. This is the v times u. Okay, the product of v times u. So our v is negative cos x. Our u, we chose our u to be sine n minus 1 x. Okay, so this is sine n minus 1 x. Okay, and then minus the integral v du. Our v is negative cos x, and our du is got our du to be equal to n minus 1. Okay, so I'm going to replace the n minus 1. Okay, and then sine n minus 2 x, and then cos x, and then dx. Okay. Okay, so we move.
Together.
Sorry.
No, I'm saying we're together.
All right.
Yeah.
Okay, and then here again, just like before, I'm going to factor out what is a constant here. N minus 1 is a constant. And if you notice this negative or this negative way, they can be multiplied, get a positive value. So plus n minus 1, and then the integral. This cosine and this cosine end up having what? Cos squared, isn't it?
Mm-hmm.
Okay, so of course squared x, and then you have sine n minus 2 x dx. Okay, now again, just like the previous problem, upon introducing this cos squared x, makes everything complicated. Doesn't make sense.
Mm-hmm.
So I have to find a way of getting rid of this cos squared x. So I have to add that cos squared x in terms of sine. So how do you do that? Identity. Okay.
Yes.
Use identity of cosine and sine. Okay. So just remember that cos squared x plus sine squared x
Is equal to
is
1.
equal to 1. Right. So I have to make cos squared x the subject. So cos squared x is equal to 1 minus sine squared x. So this is what I want to replace here. Okay.
Mm-hmm.
Okay, so we have a negative cos x sine n minus 1 x, and then plus n minus 1. In place of cos squared, I'll replace this is 1 minus sine squared x. Okay, and then I have sine n minus 2 x dx. Okay. Okay, just like before, I'm going to distribute this 1 times this sine n minus 2. This is just the same as sine n minus 2 x. Okay, and then sine squared x, and this, you see that the powers will add up. The end result just be sine n, sine raised for n. Just notice, right? So this 2 and this guys, the powers will add up. So we're going to have 2 plus n minus 2. 2 and the negative 2 cancel out, just leaving behind n. Okay.
Mm-hmm. Yes.
And this negative is minus sine n alone. Okay. X, and then all of this multiplied by dx. Okay, so again we have sine for n, what we started with here. So I have to make that the formula. Okay, we have to write that. Okay, so sine n x x. So I'm going to make this sine n here the subject formula. So what I'm going to do here, I have this negative cos x sine n minus 1 x plus n minus 1. So this integral distributed. So the first part is going to have sine n minus 2 x. The second part of minus n minus 1. The integral of sine. Oh, of course, this one has to have dx sine. Okay, so this one also needs to have dx minus again n minus 1. The integral of sine n x, again this one dx. Okay, so just distribute this integral here. Remember that integral is just linear. Okay, so I can distribute it. Okay, so I'm going to make this the subject formula. So I'll add this. I'll take it as a equation, just like what I did before. So I'm going to have sine n x dx plus, since this negative, this side plus n minus 1, the integral of sine n x dx, and this side just minus the negative cos x sine n minus 1 x, and then plus n minus 1, the integral of sine n minus 2 x dx. Okay, so that's what I have. Just like before, again, I can factorize what is common. As you can see, sine n x is common. The integrals, these two integrals are common. So I can factor out 1. So sine n x dx can be factored out. If I do so, you notice that it's just a minute 1. Okay, here just a minute n minus 1. Okay, okay, so this and this can cancel, just a minute and n there. Okay, so I can divide throughout by n, isn't it?
Mm-hmm.
Okay, so we have negative cos x sine n minus 1 x. Okay, over n plus n minus 1 over n, the integral sine n minus 2 x dx. And again, this one strictly the values of n you should take should get equal to 1. Okay, because can't have a 0 in the denominator there. Okay, to be greater or equal to 1. You notice that if you have n equal to 1, you have n equal to 1, this just be sine x. You just integrate in sine x, this will be sine the power 0, right? So this will just become 1. So the only thing you want to make is the negative cos. Here put 1 with 1 minus 1 over 1. This whole thing will die, just be 0. So the answer just be negative cos. This is true, isn't it?
Yes.
Yes. So the answer just be negative cos, and this is true, the integral sine x. Okay.
Mm-hmm. This one is much better.
So you can also try find the reduction formula for what? For cosine as well. The same approach. Okay, the same approach.
Yeah. Okay.
So
Mm-hmm.
try using finding the reduction formula for cosine. Okay, and then the last one that we have from those reduction formulas, we have the integral, this part d, the integral of x to the power n, okay, power n, and then e to the power an. E to the power ax, not an, that's ax. Dx. So I've also have to find the reduction formula for this. So here we're already given two functions, so no need to worry to split this and all that. You just have to identify which one is your u, which one is your dv. Okay. So according to that order, remember that order that we wrote somewhere there. Where is it? There's an order that I wrote here. LIATE. So if you notice our question here has what? Has exponential and exponential the last priority. So it means that our algebra, which is x power n, will be our u, isn't it? Okay, so x power n by u. So our u will be equal to x power n, meaning what remains contribute to dv. So dv just be equal to e to the power ax and then dx. Okay. So every time let u equal to that, shade that u. So du dx. So you drop the power, this is b, this will be what? N x power n minus 1. That's the derivative of that, isn't it? Okay. You have x and n x power n minus 1. That is our du dx. And then remember that you have to solve for du. So our du becomes n x power n minus 1 dx. Okay, so that is our du. Similarly, here you can find our v. So our v is just the integral of this e to the power ax dx. So how did function integrate this? So the integral that is just be the same function, okay, e to the power ax divided by the what? You divide by the derivative of the power. So what's the derivative of the power here of exponential? It's just a. So the derivative of ax equals x just be a. So that is our v. Okay. Now we can go back and replace this in our formula. Remember that we are trying to integrate. Are you there? Are you there? Or you lost connection?
Oh, can't touch the mute. I'm here.
Okay.
I'm here.
So
Yeah.
this is equal to
Very
u
much
times
so.
v. So our u is we made our u to be equal to x power n. Okay, so x power n is our u, and then our e to the power ax over a. Okay, minus the integral of v times du. So our v is e to the power ax over a, and then our du is n x power n minus 1 dx. Okay, so just like before, you have to get rid of the what? The constants. Okay, so have to get rid of the constants from that integral. So let's get rid of the constants here. So x power n e to the power ax dx is equal to x power n e to the power ax over a. So the constant here is n and a, isn't it?
And
okay, so I have e ax x power n minus 1 dx. So yeah, you're done. That's it. Okay, that's it for this.
this one I showed.
Very much. Okay. All right. So with in line with what we derived here,
let me just see the last part. I didn't finish copying. Okay.
Yes. So
Done.
in line with what we have derived here, I want us to apply now those formulas that we derived, because these are like formulas that can be applied to any function in that form. Okay. So let me just pick a few functions that we can use to apply to that. So the first function here is I'm going to pick this one here. First example. So example number 1, no? We're going to use the same. We're going to use the first example we derived, and we're asked to find the value of x power 5 natural log x squared dx. Okay, so that's the first example we're going to look at, and we're going to use this one here. Look at the formula we derived. We derived the formula for this, which looks similar to this, right? Okay, if you remember very well, we derived which formula here? This formula for this here. The first reduction formula we had x power m natural log x is for n, right? So in this case, we just have to identify what is our x and also what is our m and also what is our n, and we use this formula here. Are we together?
Yes.
Yes. So this is the formula we're going to use here. Can I copy it? I think it's easy. Let me just copy this formula. Okay. So I copy that formula. Yeah. Okay. So what was sure I can remember very well. What did I write as the formula? I just messed it up here. I thought I'd copied it. That's how I duplicated it. that I copied it, not knowing I had duplicated that.
Okay.
Yes, so I'll request if you do that for me, I did right for this. So the general formula was the integral of x power n, the natural x raised to power n dx.
Yes.
So what was
is equal to in brackets natural log of x power n,
power n?
then x, yes, then x m to the power m plus 1.
Okay.
Then divide by m plus 1.
And
Then minus n,
okay,
n over m plus 1.
Okay.
In
I think if I remember very well. Is it correct? Hello? Hello, is that correct?
hello, Steve.
Yes, is that correct?
Yes, it is.
Okay, okay.
It
right.
is, yes.
So this one is strictly for the values of n greater or equal to 1. Okay, for the values of n greater or equal to 1, and also the values of m can also be greater or equal to 1 as well. Okay, so for this one I can put the condition that n greater or equal to 1. Similarly, even m. Okay, so m also, but m can also start from 0 is fine. Yeah, I think m can also start from 0. But n should be strict together equal to 1. But since the condition here says everything, so even m can also start from 1. But even from 0, I think it gets to a line. Okay, so now this time around, we need to identify which one is our m and which one is our n. So our m in this case is the power of x here. So our m is equal to 5, or our n is equal to 2. So just have to substitute those values. So we are trying to integrate x power 5, natural log of x raised to power 2 dx. Okay, so this will be n natural log of x. Our n here is 2, so 2 squared, natural log of x squared. Our m, remember that our m is 5, so we're going to have x power 6 here over 6, isn't it? M plus 1. And then minus 2 over 6. Okay, isn't it? Here n is 2, and then 5 plus 1, we're going to 6 there. And then integrating, okay, x to the power 5, and then natural of x to the power 1, and then dx. Okay, are we there? Why is it 1
yes,
here? Because I subtracted 2 minus 1. Remember, I've put in power 1 here. Okay, so we can simplify this a little bit more. So natural of x, this is x power 6 over 6 minus, you can reduce this as 1 over 3. Okay, and then if you notice here, we still have something that we can apply. Let's apply this one to our formula. Okay, you notice that there's something new again on this part. So on this part again, we're not done. We still have, remember that I said the values of n can start from 1. Okay, well the m values can start also from 1. So you notice that they still have this is for 1. So me is now my new value. So my n new values of n will be 1. Or my m value is 3 minus 5, right? Okay, so I have to reduce that further. So what are we going to have? So we're going to have, so the first part here, I'll just keep it the way it is, because that one I'm done with it. This is natural of x squared, x squared, x power 6, okay, x squared, and then x power 6 over 6 minus 1 over 3. So now here, I'm going to repeat the same process, okay? I'll repeat the same process. What process? Now remember that my new n value is 1, my new m value is still 5. So the same process is in this formula here. Okay? So in place of n, I'll put a 1 now. In place of m, I'll still have a 5. Okay, so that will be natural log of x to the power 1. Are you following, right?
Yes, I am.
And then this will be x power 6 over m plus 1 to 5 plus 1 plus a 6 minus, here we have n now. Remember that a new n is 1, so this is 1 over 6. And then the integral, okay, we're trying to integrate what? We're trying to integrate what we have inside here. Our m is 5, okay? So this is x to the power 5. And then natural log of, okay, if you notice here, we have now 1 minus 1, isn't it? Because our m is 1. So this will be natural log of x to the power 0. So this becomes x to the power 0, isn't it? You see? So this x power, this natural log of x power 0 just be 1. So the only thing you're going to focus on integrating it is the integral of x power 5. Let me just simplify this a bit more. So natural x squared, okay, and this x power 6 over 6 minus, okay, so at this point I can dispute this to 1 over 3. So this 3 and this will be 18. So I just going to have natural log of x, and then x power 6, I can break it in front like this, and then 18 here over 18. And this negative and that negative will be positive. So we're going to have 3 times 6 again here. This will be positive 1 over 18.
1 over 18.
Tell me if you're lost there somewhere.
No, I'm following.
Okay, and this x power 5 alone, because this is just power 0, just 1, and then the x. Okay, now we're almost there. What do you think we should do here now? Integrating x power 5, right?
Yes, we integrate x power 5.
So just integrating x power 5 is very straightforward. Okay, just algebra there. The normal integration, you know. Okay. Over 6 minus x power 6 natural log of x over 18 plus 1 over 18. Integrating this is x power 6 over 6. And then over 6 dot x. And then finally, what do you do? In add this here, the constant integration. Okay, so this x power 6 natural log of x squared over 6 minus x power 6 natural log of x over 18. So you just have that job of multiplying 18 by 6, right? So that is 108. So I have x power 6 over 108, and then plus c. So this is our integral of x power 5 natural of x squared dx. Okay. Okay. Now, after deriving that, you can apply it to the question. In fact, most of the questions I've seen them saying find the reduction formula, and then from there they ask you hence or otherwise find this.
Yes.
Yes. So it just requires you to apply the formula that you found to your current problem. Oh, but if you can, none of this otherwise part where you can use whatever method you want to use. There's otherwise part. Okay. So now that is for part 1 for the first integral
formula.
the reduction formula found. Now, what of the second? How can I apply it? So do we have anything for that? I don't see anything here. Okay. Do we have anything here? I don't see any question. Okay, I don't think we have for sec squared, but you just apply anything. You just get any formula for sec, I think. Okay, you can just let it. Okay, what if we try to apply, we're trying to integrate sec to the power 4x dx. Okay, I'm just making this formula on. That's something that I came up with, right? So let's say we want to integrate sec 4 x dx, something like this, huh? I've just made up the formula myself. So we're going to use the reduction formula for sec. So you just have to know the reduction formula for sec. So the reduction formula for sec, what was it? Okay, where is it? Okay. Here. This is the reduction formula for sec. So, and I said the conditions, the values of n you have to take should get or equal to 2. Okay. Fine. Time to copy. So give me the formula for sec first. So
okay. So it's integral sec to the power nx dx is equal to tan x sec n minus 2 sec n minus 2 divided by n minus 1.
By n minus 1.
Yes, then plus n minus 2 over n minus 1
over n minus 1
over n minus 1 integral of sec to the power n minus 2 x dx.
Okay, like this. So in this case, our n is equal to 4, right?
Yes.
So I try to integrate the integral of sec 4x. Yes. So we have tan x. So this becomes what? Sec 4 minus 2 is 6 squared.
4 minus 2. Yeah.
So it becomes 6 squared, and then it's the 4 minus 1. That's 3. Yeah?
That's 3. Yes.
And then here going to have 4 minus 2. Just be what? 3 as well. 4 minus 1. Oh, 4 minus 2 is 2.
4 minus 2 is 2.
And then 4 minus 1, we have 3 here.
It's 3.
And then the integral of sec what? Squared.
2 squared. Oh.
Yes, right.
Yes.
So from this, you notice that the question is done, isn't it? Because not the integral of sec squared, just tan x, isn't it?
It's tan x, yes.
Okay. How do you know it's tan x? You can also apply that information if you're not sure. You can say, okay, now what is our new value of n here? It's 2, right?
Our new value of n is
from this.
It's 2, yes.
Yes, from this now. The new value of n is 2, so we're going to substitute 2 here. So we're going to have sec 0, 2 minus 2, just be sec 0. Sec raised for 0, right? So just be 1. So just going to have tan, okay, x over 1, right? And then if you put 2 minus 2, what do you have? Go to 0.
It's 0.
So what you're going to have just be tan x there. Don't have to waste time. Okay, so this just becomes tan x and then plus some constant integration. So that is the integral of sec to the power 4x. Okay.
Yes.
So how can I apply it? Okay, now what of the next formula? What was the next formula? It was on what?
It was on sine.
Sine. So do you have anything for sine? Okay, so I have this one, sine the power 7 x. No example here.
X dx.
So we have the integral of sine to the power 7 x dx. Okay, that's what I need. So first of all, write the formula for sine to the power n. What was the formula?
It's integral. Yes, sine to the power n. Oh, okay. Okay, is equal to negative cos x.
Negative cos x.
Sine to the power n minus 1 x.
Over.
Divide by n over n.
Okay.
and then plus n minus 1 over 2.
N minus 1 over?
Over 2, then integral of sine n minus 2.
Sine n minus 2.
To the power n minus 2x.
Like this.
Yes.
Okay. This is n minus 1 over n, not 2. So, I'll surprise and mention 2. Okay? That is not true here. It's n. N minus 1 over n.
Oh, okay.
So make that correction.
Okay.
Okay. So our n, what is our n in this case?
7.
7. Okay. Our n is equal to 7. So we're trying to integrate this. So we're going to integrate in sine 7 x dx, and this is equal to negative cos x, so cos x, okay. And then sine
To the power 6.
6, right? Yes. And then over 7, isn't it?
Over 7, yes.
And then plus this will be 7 minus 1,
6
just 6
over
over
7.
7. And then the integral of sine the power 5.
The
Right?
power 5. Yes.
Okay, the 5x dx. Now again, we are going to work on this as our new problem, isn't it? So in this case, what is our n now? Our new n is what? 5, right?
Oh, our new n is 5, yes.
So our new n is 5.
Oh, yeah.
So again, we repeat this. The problem using the same formula here. Repeat it. So our new n is 5. So we're going to have negative cos sine the power 4x, right? Negative cos, and then sine the power 4
To the power 5.
x over 5, right?
Yes.
From the formula here, and then plus 4 minus 1 or 5 minus 1 over 5. That is 4 over 5.
4 over 5.
And then trying to integrate the integral of sine squared x, isn't it? Cos now. Oh no, sine cube.
Sine cube, yes.
Isn't it? Cube, right? So
Yes.
I try to integrate sine cube x dx. Okay. Okay, so what do we get here? We have negative cos of x sine 6x over 7 plus 6. Okay, so this time around, what I'm going to display is 6 over 7 times that. So I'm going to have negative, so this will be negative 6 cos x sine to the power 4x over 35. Okay.
Over 35.
And then similarly here, this 6 over 7 times 4 over 5. Those guys can be multiplied so that you get is 6 by 4, you're 24 over 35. The integral of sine cubed x dx. Now again, you have to apply this here. Our new value of n is what? 3, isn't it?
It's 3.
Okay, and to reduce it, something can easily integrate. So of course, x sine 6x over 7 minus 6 cos x sine the power 4x over 35 plus 24 over 35. Again, we repeat the process here. So we're going to have a negative cos sine squared over 3. How is this squared? It's because we're still applying this formula here. So now n is 3, so this will be 3 minus 1 sine squared over 3. And then you're going to put 3 minus 1 over 3, just put 2 over 3 here. okay, and then plus 2 over 3, and then the integral again of what? This integral of what? Sine 3 minus 2, just the sine of
3
x,
minus
isn't it?
2. Sine of x, yes.
So just the sine of x. Okay, so going to get sine of x dx. Okay, almost there. So negative cos x sine 6x over 7 minus 6 cos sine power 4x over 35 plus, okay, so this is 24 over 35 by 3. So what is 35 by 3? Okay, that's 105, isn't it? Okay, so that is
yes, it is.
So negative of course because it's negative prime, so it's 4 over 105, and then cos x sine squared x, okay, and then 24 by this we have 48, and of course you can also find what's the integral of sine here? Negative cosine.
It's negative cos, yes.
Okay, so let me just simplify this first. So 24, no, sorry, 48.
48.
48 over 105, and then trying to find the integral of sine x sine dx. So what we have here, we have negative cos of x sine or 6x over 7 minus 6 cos this cos x sine the power 4x over 5 and then minus 24 cos whatever there sine squared x over 105, and then for this part we're going to end up with negative cos, isn't it?
Negative
so this
cos, yes.
comes minus 48 over 105 cos x.
Cos x.
And then plus the constant of integration. Okay, so this is the integral of sine 7x dx. Okay, so it's easy when you have the reduction formula already.
When you have the formula, yes.
Yes, just substitute. So every time we are given such complicated integral, yeah, just find this reduction formula, and then from there, then you see what to do. Okay, so what I'm going to do here, I'm going to end this video, but I don't this video only that alone, and then we can look at something else. But I will quiz at 8 hours. I think I need to rest a bit for it. Let me just rest a bit, and then you can resume later on.
All right. Okay, let me just go through this again.
Let me just rest a bit. So we are done with that formula, right? No more questions.